Have you ever wondered what makes a car feel the way it does? It's not just the fancy seats or the shiny paint. Well, deep inside, under the bonnet, lies the heart of the machine, the engine. This is where the magic happens. It's where fuel and air mix, ignite, and create the power that pushes you down the road. But not all engines are created equal. They come in all sorts of shapes and sizes, and the way the parts are arranged inside has a massive impact on everything. It affects how the car sounds, how it handles around a corner, and how much space you have for your shopping in the boot. It's a fascinating puzzle of engineering. Think of it like this. An engine is a collection of cylinders like small power factories. The way you arrange these cylinders changes the engine's personality. You can line them up in a neat row, you can angle them apart to form a V, or you can lay them down flat. Each layout is a different solution to the same problem. This choice is one of the first a designer makes, and it sends ripples through the whole vehicle, from front bumper to rear axle. This guide is your key to that hidden world. We are going to lift the bonnet and look at all the major engine layouts. No jargon, no complicated physics, just simple explanations. We will explore why a small city car has a different engine from a big, brawny supercar. We'll cover pros and cons, from the inline-4 to the V12 to the rotary engine. By the end, you'll be able to spot the differences and know why they matter. We'll start with the most common layouts, then move to the exotic designs in performance cars. For each one, we'll explain what it is, how it works, and show famous examples. This isn't just for mechanics, it's for anyone who loves cars. So, let's get started and dive into the brilliant world of engine layouts. Before we get into the nuts and bolts, let's get a quick lay of the land. The world of engines can be broken down into a few key families. Inline engine. The cylinders stand upright in a straight line. You'll find these everywhere. V engine. Two banks angled apart, forming a V. Famous in muscle cars and high-performance machines. Boxer or flat engine. The cylinders lie flat and punch outwards, like a boxer throwing jabs. Loved by brands like Porsche and Subaru. These engines can also be placed in the car in two main ways. Transverse. The engine sits sideways in the bay, saving space. Most front-wheel drive cars you see today use this setup. Longitudinal. The engine sits front to back, pointing down the car. Typical in rear-wheel drive and performance cars, helps with balance and sending power to the back. The placement is just as important as the engine's shape, dictating much of the car's character and capability. Beyond these common types, there are also a few specialists. The W engine, like two V engines squashed together. It's a rare beast, most famously used by Bugatti. And we can't forget the rotary engine. It doesn't use cylinders at all. Instead, it uses a spinning triangular rotor to create power. It's a brilliantly simple idea with its own unique advantages and challenges. Understanding this basic taxonomy is the first step. It's like learning the different families of animals before you study each one up close. In this guide, we'll take a closer look at every single one of these layouts. We will break down why an engineer might choose one over the other. Is it for cost, for pure, unadulterated performance, or for perfect balance and handling? Each layout represents a different set of priorities. By exploring them one by one, you'll gain a complete picture of why cars are the way they are, right from their very core. Let's start with the most fundamental and common engine layout of all, the inline engine. You might also hear it called a straight engine. All the cylinders are arranged in a single straight line, standing vertically side by side. Think of it like a loaf of bread, with each slice being a cylinder. This simple, elegant design is the grandfather of modern engines. In fact, the very first production car, the Benz patent motor wagon from 1886, used a single-cylinder engine. It's the simplest inline engine possible. It's easy to understand, easy to build, easy to work on. The inline layout comes in a few common sizes. The most widespread is the inline-4. Lift the bonnet of many small or medium cars and you'll find one. Toyota Corolla, Volkswagen Golf. They're cheap to manufacture, compact, fuel efficient. A smaller, increasingly popular version is the Inline-3, more economical. On the other end is the legendary Inline-6, naturally balanced and incredibly smooth. A hallmark of premium brands. BMW Jaguar. The main advantage is simplicity. One cylinder head, one camshaft, or two camshafts for DOHC, a straightforward crankshaft. Fewer moving parts than complex layouts. Lower manufacturing costs, easier maintenance, hard to change spark plugs on a V engine versus easy access on an inline. Firing order, the cylinder ignition sequence, can be tuned very smooth, especially in an inline-6. Forces from moving pistons cancel each other out. Result, silky, vibration-free operation. No design is perfect. Biggest drawback, length. Add cylinders. Engine gets longer. Inline-4 is compact enough. Inline-6 can be long to fit. Inline-8 is almost unheard of today. Length makes packaging difficult, especially in small cars. A long inline engine can't easily be mounted sideways. That limits use in many front-wheel drive cars that dominate the market today. Packaging is why many moved from inline-6 to compact V6 engines. When the length of an inline engine becomes a problem, engineers have a clever solution: the V engine. Imagine you have a long inline-6 engine. Now picture splitting it down the middle, with 3 cylinders on one side and 3 on the other, and arranging them at an angle. What you get is a V6. The 2 banks of cylinders form a V shape when viewed from the front, connected at the bottom to a single crankshaft. This ingenious layout allows you to fit more cylinders into a much shorter, more compact package. This is why V engines, particularly the V6 and V8, have become the go-to choice for larger cars, trucks, and performance vehicles where power is a priority. The most famous member of this family is undoubtedly the V8. It's the sound of American muscle, the heart of European supercars, and the workhorse of big pickup trucks. The firing order of a V8, especially a cross-plane crankshaft design common in American cars, creates an uneven burble that is instantly recognizable. The V6 is the V8's smaller sibling, offering a good compromise between the power of a V8 and the efficiency of a smaller engine. You'll find V6 engines in everything from family saloons like the Toyota Camry to sports cars like the Nissan Z. The primary benefit of the V engine is its packaging efficiency. A V8 engine is significantly shorter than an inline-8 would be, and a V6 is much more compact than an inline-6. This shortness means it can fit into a wider variety of vehicles, and it also leaves more room in the engine bay for other components like turbochargers, cooling systems, or hybrid electric hardware. The V-shape also creates a very rigid and strong engine block, which is great for handling the high pressures and forces generated when making big power. However, this compact power comes at a cost. A V engine is far more complex than an inline engine. It requires 2 cylinder heads, double the number of camshafts, and a more complicated exhaust system. All these extra parts add weight, complexity, and most importantly, cost to both manufacturing and maintenance. V engines also have inherent balance issues that inline-6 engines do not. While engineers use clever counterweights and balance shafts to smooth them out, a V6 is never quite as naturally silky smooth as a straight 6. It's a classic engineering trade-off: compactness and power in exchange for simplicity and smoothness. Now let's look at a layout that takes a completely different approach. Instead of standing cylinders up in a line or a V, the flat engine lays them down. The cylinders are arranged in 2 opposing banks on either side of the crankshaft, lying horizontally. When the pistons move back and forth, they look like they are punching each other, which is why this design is often called a boxer engine. While other types of flat engines exist, the boxer configuration is by far the most common in cars today. Porsche, which has used it in its iconic 911 sports car for generations, Subaru uses it across almost its entire model range. The defining characteristic of a Boxer engine is its incredibly low profile. Because the cylinders are lying flat, the entire engine is not very tall. This gives the car a much lower center of gravity than a vehicle with a tall inline or V engine. A lower center of gravity is the holy grail for car handling. It reduces body roll when you go around a corner, making the car feel more stable, planted, and responsive to the driver's inputs. Another major advantage of the Boxer design is its excellent primary balance. In a true Boxer engine, each piston's movement is directly canceled out by the corresponding piston on the opposite side moving in the opposite direction. This opposing motion means the forces largely negate each other, leading to a very smooth-running engine. Despite these brilliant advantages, the flat engine is not very common. The main reason is its width. While it is not tall, it is very wide, which can make packaging a challenge. This width also makes maintenance more difficult. Simple tasks like accessing the cylinder heads or changing spark plugs can be a real headache because they are tucked away deep in the sides of the engine bay. The design is also more complex and expensive to manufacture than a simple inline engine, which is why it is typically found in more premium or specialist vehicles, rather than budget-friendly hatchbacks. It's not just the shape of the engine that matters, but also which way it points. There are two primary ways to mount an engine in the front of a car: transverse, longitudinal. A transverse engine is mounted sideways, or east-west, with the crankshaft running parallel to the front axle. This is the most common layout in modern cars. Almost every front-wheel drive car you can think of, Honda Civic, Ford Fiesta, uses a transverse engine. The reason is simple: packaging efficiency. By placing the engine and the gearbox sideways, you create an incredibly compact power unit. This takes up very little of the car's overall length. This space-saving benefit is enormous. It means, for a given vehicle size, you can have a much larger passenger cabin and more luggage space. However, there are limits. Fitting a long engine, like an inline-6 or big V8, sideways is extremely difficult. Transverse layouts are almost always limited to inline-4 or V6 engines. The alternative is the longitudinal layout. Here, the engine is mounted north-south, with the crankshaft pointing down the length of the car, from the front bumper towards the driver. This was the original layout for cars and remains the standard for most rear-wheel drive and many all-wheel drive vehicles. Think of a classic sports car like a Ford Mustang, a luxury saloon like a BMW 3 Series, or a rugged SUV. The main advantage of a longitudinal engine is better weight distribution and balance. Because the engine can be pushed further back in the chassis, sometimes even behind the front axle, it helps to centralize the car's mass. This typically leads to more balanced handling, which is why it's the preferred layout for performance and luxury cars where the driving experience is paramount. The choice between transverse and longitudinal is a fundamental one that defines a car's priorities: space efficiency or dynamic performance. We've touched on how an engine's layout affects a car's balance, but it's worth diving a little deeper into this. The position and shape of an engine have a profound effect on a vehicle's center of gravity and weight distribution. A lower center of gravity makes a car more stable and less likely to roll over during hard cornering. It feels more planted and gives the driver more confidence. This is where the Boxer engine, with its low, flat profile, truly shines. This is why a Subaru WRX or a Porsche 711 8 Cayman has a reputation for feeling so glued to the road. Their engine layout gives them a built-in advantage from the very start of the design process. Weight distribution is the other half of the puzzle. This refers to how the car's total weight is split between the front and rear axles. The ideal for a performance car is often considered to be a perfect 50-50 split. A car with too much weight over the front wheels, which is common in transverse-engined front-wheel drive cars, can tend to understeer. This is where the front of the car wants to push wide in a corner. A longitudinal engine, especially when mounted further back in a front mid-engine position, helps shift weight towards the center and rear of the car. This improves traction for the rear wheels and creates a more neutral, balanced handling feel. A Porsche 911 takes this to the extreme by placing its flat-six engine right at the back, behind the rear axle, creating a unique rear-biased weight distribution that gives it incredible traction when accelerating out of corners. Now that we understand the basic shapes of engines and how they can be mounted, let's connect the dots to the drivetrain. The drivetrain is the collection of components that delivers power from the engine to the wheels. The choice of engine layout is deeply intertwined with which of these systems a car uses. It's a fundamental decision that affects everything from the car's cost and complexity to how it behaves when you put your foot down. Front-wheel drive, as the name suggests, means the engine's power is sent only to the front wheels. Animation. This system pairs almost perfectly with a transverse engine layout. By mounting the engine sideways, the manufacturer can create a single, compact unit. This simplicity is a massive advantage. It means fewer parts are needed, which makes the car cheaper to build, lighter, and more fuel efficient. Rear-wheel drive is the traditional layout for automobiles. In an RWD car, the engine sends its power to the rear wheels. This setup is the natural partner for a longitudinal engine. This layout is inherently more complex and costly than FWD. It takes up more space. However, it offers significant performance advantages in terms of handling balance and acceleration, which is why it remains the choice for sports cars. All-wheel drive is the jack of all trades, sending power to all four wheels. AWD can be paired with either a transverse or a longitudinal engine. In a transverse setup, like in many SUVs, the system is typically a modified FWD layout. In a longitudinal setup, found in performance cars like a Subaru WRX, the system is often designed for permanent all-wheel drive, providing maximum traction and performance in all conditions. Section 1. The W engine, a compact powerhouse. Now we venture into the truly exotic. A W engine is like merging two V engines together. Imagine taking two narrow-angle V6 engines and joining them at the crankshaft. What you get is a W12. This clever engineering was championed by the Volkswagen Group as a way to get a very high cylinder count in a compact package. The main motivation behind the W engine is packaging. The most extreme example is the W16, Bugatti Veyron, Bugatti Chiron. This is essentially two V8 engines fused together. It packs 16 cylinders and 4 turbochargers into a space not much larger than a conventional V12. The silky smooth V12, the pinnacle of luxury. A V12 engine consists of two banks of 6 cylinders arranged in a V configuration, typically at a 60-degree angle. This layout is special because it is inherently perfectly balanced. A V12 is essentially two inline-6 engines joined at a common crankshaft. As a result, it shares that same perfect balance, resulting in a power delivery that is almost completely free of vibration. This incredible smoothness is why the V12 has long been the engine of choice for the world's most prestigious luxury cars. Rolls-Royce. The V12 is not just for luxury limousines. It is also the heart of legendary Italian supercars from brands like Ferrari and Lamborghini. The Wankel rotary engine. Instead of pistons, the rotary engine uses a rounded, triangular-shaped rotor that spins inside an oval-shaped housing. First, it has very few moving parts. This simplicity makes the engine incredibly compact and lightweight for the amount of power it produces. The rotary engine is most famously associated with Mazda, in cars like the iconic RX-7. However, the rotary engine has some significant, well-documented flaws. The apex seals at the tips of the rotor are notoriously difficult to lubricate and are prone to wear. Rotary engines are also not very fuel efficient. The mid-engine supercar layout, when absolute performance and handling are the ultimate goals. In this configuration, the engine is placed between the driver and the rear axle. This concentrates the car's mass at its very center. a bit like how a figure skater pulls their arms in to spin faster. This results in the lowest possible polar moment of inertia. It means the car is incredibly agile and can change direction with breathtaking speed and minimal effort. This is why nearly every modern supercar, from a Ferrari 296 GTB to a Lamborghini Revuelto or a McLaren Artura, uses this layout. The main drawback of the mid-engine layout is its complete disregard for practicality. Placing a large, hot, noisy engine right behind the seats eliminates any possibility of having rear seats. Luggage space is also severely compromised. The future, hybrids, electric motors, and beyond. In a modern hybrid supercar, the petrol engine no longer works alone. Take the Ferrari SF90 Stradale. A V8 powers the rear wheels, while two independent electric motors drive the front wheels. That makes a sophisticated AWD system with no physical link between axles. It enables instantaneous torque vectoring, power to each front wheel adjusted millisecond by millisecond to pull the car through a corner with insane agility. Fully electric cars remove the traditional engine layout entirely. An EV's engine is a compact electric motor, leading to the skateboard platform, a large flat battery under the floor with motors at the axles. This architecture fundamentally changes car design. No big front engine bay means shorter bonnets and much more interior space. Low central battery placement gives an extremely low center of gravity, which hugely benefits handling and stability. The shift to electric ushers a new era of packaging efficiency and performance that will redefine how cars are designed, built, and driven. Section 1. The engine layout jigsaw puzzle. So there we have it. We have journeyed deep into the heart of the car. We've seen that the choice of an engine shape and position is far from a trivial detail. It is a fundamental decision that dictates almost everything about a car's character. Inline engine. Simplicity and smoothness. Downside, length and packaging. V-engine, compact power in a short block. Downside, complexity and weight. Boxer engine, low center of gravity for superb handling. Downside, width makes packaging and maintenance difficult. This journey reveals a core truth of automotive engineering. There is no single best engine layout. The ideal choice depends entirely on the car's intended purpose. Section 2. Practical advice. Choosing your car. Now, what does all this mean for you when you're looking to buy a car? Armed with this knowledge, you can look beyond the color and the infotainment screen and make a more informed decision. A simple, common engine like a transverse inline-4 in a popular hatchback is going to be the cheapest to run and the easiest to get serviced. Think about how you will use the car. If fuel efficiency is your top priority, a smaller inline-3 or inline-4. If you need to tow a heavy trailer, the low-end torque of a large V8 or a diesel engine is essential. If you live somewhere with harsh winters, the combination of a boxer engine and all-wheel drive offers incredible security. The engine layout isn't just a technical specification, it's a feature that directly impacts the car's capability and suitability for your lifestyle. Section 3. The view from the driver's seat. Ultimately, the goal of this entire guide was to connect the engineering under the bonnet with the feeling you get behind the wheel, the subtle vibrations you feel, the sound that fills the cabin as you accelerate, the way the car turns into a corner. All these sensations are deeply influenced by the engine's layout. When a Ford Mustang rumbles past with its iconic V8 burble, you'll know that its longitudinal layout is key to its muscle car character. You'll appreciate that the low-slung, planted feel of a Porsche Cayman is no accident. It's the magic of its mid-mounted boxer engine at work. So, the next time you turn the key and feel that initial thrum of life from the engine, take a moment to think about what's happening. Is it a row of pistons standing to attention? Are they punching outwards like a boxer? Or are they arranged in a powerful V? You now have the keys to understanding the very soul of the machine. You understand the language of layouts, And that, I believe, is one of the most exciting things about being a car enthusiast. Enjoy the drive.